Oh man, I got such a headache.
Mr. Davidson, we have appeared to get your x-rays back.
And what's up?
You appear to have a credit card lodged in your brain.
Oh, how'd that happen?
Well, I'm no engineer, but
Microplastics have become an increasingly worsening issue in our global ecosystem. These particles exist in the air we breathe, the water we drink, and the food we eat. These plastic particles make their way into the bloodstream where they can travel to many of the body's major organs. In the brain alone, there are 5 to 7 grams of microplastics. That's about the same as how much a credit card weighs.
Microplastics, or more commonly known as tiny plastic fragments that are less than 5 millimeters, have been an ongoing global issue. Due to their tiny structure, they are easily transported through the environment around us, such as through our waterways, ultimately affecting not just the aquatic life at play, but then those microplastics could end up within us as well, through the ingestion of seafood, for example. Therefore, microplastics are not only confined to the environment, but have also become a threat that is rapidly affecting human health.
For our proposed solution, we identified 5 design requirements and 5 evaluation criteria that our design should satisfy. Our proposed design requirements include 1. Filtration efficiency. Our design must be able to reduce, filter plastic to some extent. 2. Durability. Our filtration device will not be easily swept away in various weather conditions. 3. Cost efficient. The cost of the final product is somewhat acceptable for middle-class consumers. 4. Non-disruptive. It will not disturb swimming areas, aquatic ecosystem, and/or private property owners. 5. It will follow public regulation. The design will stay within health, public, and government regulations to ensure the product can actually be implemented. Next, our evaluation criteria include 1. An easily changeable filter, allowing for safe disposal and an effortless cleanup. 2. The filter can withstand and operate in all weather conditions. 3. It would be ideal if the filter was constructed out of reusable materials. 4. The filter is to be easily inserted or removed from the water. And 5. Our proposed solution is to contain multiple layers of filtration pores to allow for various sizes in microplastics.
Based on our design requirements and evaluation criteria, we went through several selection processes to determine our final solution. Introducing the PET fish. This is a filtration device resembling a fish that flows through the water and collects microplastics. It is made of filters and pores to absorb different sizes of plastics. Water flows through the current and enters the fish. The plastics in the water get trapped in the filter, where they are collected and contained in the back of the fish. When the filter needs to be changed, the tail is able to unscrew and the absorbed plastic can be collected. The leftover water exits out of the fish, now clean from the plastics that are so harmful to the aquatic system.
Our first prototype for the pet fish was a focus sketch. It shows the general shape of the fish as well as a few indications of some of its design attributes, such as water input and output and LED eyes to show when the filter needs to be changed. Our next prototype was a focused diagram of the internal filter. In this diagram, we started to focus more on what the device would be made of. We found that reusable materials like stainless steel, silicone, and other natural materials would be best to ensure safe recycling at the end of the device lifespan, which would be over a few years.
The fish includes a microplastic filter, which could be a modified washing machine filter, as well as internal panels to shift the water throughout the fish. Our final prototype was a focused 3D model, which allows us to visualize details that a 2D drawing cannot. And using this prototype, we can see how the internal and external parts of the fish connect and work together. This model is vital to bringing the project to life and can be further improved with stakeholder interaction.
finally, to conclude, every decision made will always have corresponding consequence, constraint, or limitation. For our project, we identified 2 major limitations and constraints. 1. There are many constraints and real-world issues that we didn't consider. These constraints include any and every possible decision and assumption we made prior to our final project's limitation stage, as a proposed solution for those decisions and assumptions were made very briefly and simplified. This is because in reality, there's going to be way more complicated factors that may partake and affect any stage of our decision-making steps. Factors may include the transition from conducted virtual plans to a real-life plan, the products and limitations in scalability, function, and efficiency. 2. Finally, our last and biggest assumption is that every step in our project planning will fall into place with no major failure that may result in major delay during our project's implementation stage.
So what does this have to do with me?
Well, you could invest in the fish and help get microplastics out of the water.
Well, how does that help get the credit card in my head?
Oh, it doesn't.